Okay, so in this video, we're going to talk about pages 71 to 74, which cover arcs and central angles. So if you've printed this out, this is one of those shutter folds. So what I'm looking at right now, after you fold it, should be like the front of yours. So this empty space is what you glue in. You're folding along the middle part. So I'll draw some lines in there. So if you're folding essentially like here and here, and then cutting there and there, and then cutting along those dotted lines so that we'll talk about the vocab term and then go to the definition. So it's going to look a little funky in here because they don't line up, but when you print it double-sided, they will. So the first thing we're going to talk about is central angle. So central angle is an angle inside of a circle. And so this is an example of a central angle. So angle AOB is a central angle. Arc AB is an arc. So that curved value is an arc. Notice that they both have the same degree measure. Those both are 56 degrees. So the measures of them are equal. So let's look at the definition of a central angle, which is over here. Again, when you flip on your paper, it'll line up a little bit better. So a central angle is an angle whose vertex is at the center of the circle. The way that we name central angles are as we would any angle where we have the endpoints and the vertex. So an example of a central angle would be this angle here, angle ACE. There's lots of different central angles in here. I could also do, if I just go around, ECF is a central angle. Another central angle would be FCD. And then the final central angle that we can see is angle ACD. So remember that when I'm naming an angle, the only thing that's the most important is that the vertex of the angle is that middle letter. So that middle letter should be the center of the circle because that is the vertex of a central angle by definition. So I could switch the order of the other two letters, the two that I didn't highlight, and that would still be a correct name for each central angle. Okay, so let's look at the next symbol. So we'll just go down here. So the next one is a minor arc. So notice that we have the same picture for the major arc and the minor arc. So in this visual, we see that a minor arc is less than 180 degrees and a major arc is greater than 180 degrees. So a minor arc by definition then is an arc with a measure less than 180 degrees. It is named by its endpoints. So visually, if I think about arcs on here and I want to find one that looks like it's less than 180, I know for sure that this arc, because it's 45 degrees, is less than 180. So arc AE would be an example of a minor arc. So again, the endpoints are A and E. I use an arc across the top to denote that it's an arc. So another example, E to F would be a minor arc. Okay, so EF, that's less than 180 degrees. Visually, I know because 180 would be the diameter. D to F would be another minor arc. And finally, this other one, AD, also looks like it's less than 180. So AD would be a minor arc. One thing to kind of remember with minor arcs is that they're always just used two letters. So a minor arc only uses two letters in its name. A major arc, I'm not going to go back to the front. Let's just do this from here. So then a semicircle is the next word. So semicircle is an arc that measures exactly 180 degrees. And so it's named by its two endpoints and one point in the semicircle. So in this diagram here, they're telling us that ED is a diameter. And so a semicircle is always made with a diameter. So if ED is a diameter, that means that the arc from E to D but I have to use a letter in between. So I could name that as E, B, D, and that would be a semicircle. I could use the F. I don't have to use the B. The B I use because it's just kind of hanging out there. I couldn't use it as an endpoint. It's not an endpoint. I could call it E, F, D, and those are referring to the same arc. Notice that I could change this and I could do E, A, D, and that would be the other half of the circle. Okay, so I could name it EAD. And again, those two endpoints, I could switch the order and do DBE, DFE, or DAE, and those would all be appropriate. One thing to note is that this one, again, always has 3 letters. So anything that is 180 degrees or larger, we're going to use 3 letters to name it. The final is a major arc. So a major arc is an arc whose degree measures greater than 180. We name it the same way that we would name something from the semicircle. So if I'm thinking about a major arc, one major arc that I could do is from A to E, but not directly from A to E. I want to go the other way around. So if I went from A to E the long way, I could go A towards D and then stop at E. So a name would be A, D, E. And again, I could replace that D with any of the other letters that are in between A and E if I go that direction. So I could do A, F, E, I could do A, B, E. Okay. I'm not going to write out all of those possibilities though, but I will do another arc. So if this arc 60 degrees, then I know that the rest of the circle's 300 because a full circle is 360. So if I go from D to F, not directly, but the other direction, I could go from D towards A. So I could say A, I could say E, I could say B, I could say any of those 3 letters. So D, and then again, I have a choice between 3 letters. So we could just do D, A, F. Okay, so any arc that is greater than 180. So I could go from A to D as well, this direction. So I could do A, B, D. That would be a major arc. Again, there are a lot of major arcs in here. I'm not going to name all of them. One thing to remember is that you use 3 letters for these. Okay, so we've got central angles and arcs. They use the same degree measures. So if I'm given the measure of an arc, I can use it to find the measure of its corresponding central angle. So let's go through and look at this. The only things that we know is that arc AE is 45 degrees and arc DF is 60 degrees. So what that also tells us then is that the central angles that are across from them are also those same measures. So I know that this is 45 degrees here and that this is 60 degrees here. Okay, remember that ED is the diameter. So I know that that is cutting my circle in half so that each of those are semicircles. Okay, so we're looking for angle FCD. Okay, so we've already talked about that. That must be 60 degrees then, because arc DF is 60 degrees, so the angle inside that arc is also 60 degrees, and that is a central angle. I'm going to highlight that real fast and I'm going to erase it, so don't do that if you're copying. So it was talking about that angle. That's why we got that it was 60. So I'm going to highlight but then erase every time just so you can kind of see what these are talking about. So measure of arc AE. So arc AE goes from A to E, and that one's actually given to us. So we know that that's 45 degrees just because of what we were given. I'm going to change the color just so that. And that is a minor arc. Again, it's a minor arc because it's less than 180. Okay, next we've got arc ADF. So if I start at A, I go towards D, and I stop at F. Okay, so What I know about this is that that red line divides it in half. So I know that from A to D is 180, but 45 degrees less because 180 is that red line. So what I can do to figure out what this arc is from A to D is I can do 180 minus 45 so that I can just figure out what this wedge is from where the highlighted part is. And so that means that that's 135 degrees there. Okay. And so that means that my arc that I'm looking for is 135 plus 60. And so that means that that's 195 degrees, which makes it a major arc. So I'm going to erase that highlighter so that I can do the next one. Again, I'm just not highlighting a bunch, each one a different color because it would become a mess because we're doing quite a bit of these. So then is arc AD. So actually that's the one that we just found. So we just figured out that arc AD is 135 degrees. And so that makes it a minor arc because it is less than 180. And then the next one is the measure of angle ACD. So from A to C, whoops, I didn't get a highlighter, sorry. From A to C to D. Okay. So that is the angle that holds arc AD. So that's going to be the exact same measure as the last answer. So that's also going to be 135 degrees. So 135 for arc AD. Again, that's a central angle. So then looking at the notation, I know that this next one is also a central angle because I don't classify the angles. So to find the measure, I have from A to C to F. So this angle here, ACF. And so this one uses that last wedge that we don't know how much it measures just yet. But the same way that we found that wedge from A to D, we can find the measure of the wedge from E to F because that red line, again, is our diameter. So that's 180 degrees. And so if I know that this smaller wedge is 60, then I can do 180 minus 60. And so that means that this piece is going to be 120 degrees. Okay. Then we have arc A to F to D. So I'm going from A towards F. So F is this direction and stopping at D. So if I look at each of those wedges, I know their measures individually. So I just need to add them together. So I need to add 45. And then actually I can just do this as 180. So I know that that's a semicircle. So if I add 45, plus 180, that's going to give me 225, which means that this is a major arc. Again, because that number is larger than 180. Sorry, I wrote major AC. Let me fix that. Okay, our last arc is the arc from F to E. Start at F, go towards D, and stop at E. So starting at F, D is over here, and I'm stopping when I hit E. Okay, so if I look at this one, I have kind of a similar situation. So from E to D is the 180, right? That's my diameter. So I can just do 60 plus 180. I could also do 60 plus 35 plus 45. So whatever kind of is what you see from the start, that's how you should figure out those answers. So if I do 180 plus 60, that's going to give us 240 degrees, which makes this a major arc. Okay, so that's all we're talking about today. On the next page, we're doing more of this simple stuff, and then it's going to get to be more complicated where we have variables and stuff. So this is a kind of a long lesson. So the next one is just having us look at this other diagram and identify some arcs. So if I have circle with center E, so this notation is telling us we have a circle with center E, and we're going to use it to answer questions 1 through 8. So NL is the diameter. So NL then makes this so that this side is 180 and this side is 180. Okay. So looking at that, we can figure out what the other pieces are right now and then just kind of use those to find the other answers. So remember that if I have this labeled as a right angle, that means that this is also 90 degrees. So since I have, this is 180, I know that this 90 plus another 90 gives me that 180. For the last wedge, if we do 180 minus that 22, that means that this one is 158 degrees. So 90 plus 90 plus 22 plus 158, that gives us all the pieces. So that's a good place to start when you have something small and there's only 4 pieces. It's easy to find those measures. And then we can just add things together to find the answers. So I'm going to do the same thing where I highlight and then I'll erase it. So you shouldn't copy the highlighting. So arc NW was given to us. And so that is 22 degrees. I'm going to use blue just so that we can see it. Okay, 2 is the measure of arc KNL. So from K towards N, and then we're stopping at L. Okay, so I'm going from K to N to L. So I have a couple different options on how I can figure out what this is. Again, remember that red line always represents 180. So since I have a full 180, I can just do 180 plus 90, which gives me 270 degrees. Remember that I could do 90 plus 22 plus 158, but it's good to kind of pull that 180 whenever you can for a problem. Okay, so I'm gonna erase that. And now this one's just asking us from K to L. So that's always the shortest distance when I have two letters to represent the arc. So that's my right angle. So that means that that one is just 90 degrees. Next, we're starting at N, going towards K, and stopping at L. So notice that that's my diameter, NL. And so that means that that is the semicircle, which is 180 degrees. Then I want to go from K to W. So our KW, again, remember that since there's 2 letters, that means it's the shortest distance. So notice if I were to go KLW, that's going to be bigger than 180, which means it would be a major arc. But the notation, this tells me that I'm going the shortest distance, okay, because there's only 2 letters. I should probably write that. So whenever there's 2 letters in the arc, that means you're going that shortest distance. So from K to W is this. So that means we're doing 90 plus 22. So this is going to be 112 degrees. Versus KLW, now that's asking us for the other piece. So from K to L to W, that's going to be 90 plus 158. And so that's going to give us 248 degrees. I'm going to box these answers where I showed work just to make sure that that's clear. Okay, so last 2, we've got LKW. So I'm starting at going towards K and stopping at W. Okay, so from L to N is 180 because that's my diameter plus 22. So I'm going to do 180 plus 22. Again, I could always do 90 plus 90 plus 22 and just add each wedge together. Either way, that's going to give us 202 degrees. So that guy's a major arc. Okay, last one on this page is from N towards K, stopping at W. So that's all the way around. okay? And so we could do this two different ways. When I have everything except for one wedge, I could always do 360 minus that. Or I can do, I've got 180 from N to L plus 158. Right? Or I could do the 90 plus 90 plus 158. No matter how we do that, we should get 338 degrees for that major arc. Okay, so that is arcs and central angles, where I'm just using numbers and I'm just adding, subtracting, working with 180, 360, that kind of thing to find values. Next, we're going to look at relationships. And so for these ones, we're solving for the variable in each of these. So on page 73, we're doing central angles and arcs. And then same thing for 74. So they're just going to be more complicated in the sense that we have to do some algebra to solve the problems. So one thing to notice is that it might not tell us some things the diameter, but we can see things that are diameters. So notice that RT and US are straight lines. So that means that those are diameters. And so that means that this is all 180. Okay. So what I can do to solve this problem then is use that idea. So I know that this first arc, RS, is 15x minus 26. So that means that 15x minus 26 plus the arc ST, which is just 26, I know that that has to be 180 because I've got a diameter. Okay. So I'm going to solve this for x. The question is just asking for x. So once we do that, we're done. So if I combine like terms, 15x minus 26 plus 26, those are going to cancel so that we just have 15x equals 180. So then if we divide both sides by 15, that's going to give us that x is 12. Okay, so then for problem 2, notice that EG is a diameter and HF is a diameter. So one thing to know about diameters is they create vertical angles. So remember that vertical angles are angles that share a vertex but are across from each other. And those are equal. So that means that I know that since this is 103 degrees over here, that this also has to be 103 degrees. So what I can do is add those together, but this time I'm going to set it equal to 103. Okay, so I'm going to take 18x minus 2. I'm going to add that with 15. And I know that that must be equal to 103. So if I combine like terms, 18x minus 2 plus 15, I can combine these two numbers. That's going to give us 18x plus 13 is equal to 103. So then to solve for x, we want to subtract 13 from both sides. So 18x is going to be equal to 90. Which means that x is 5. This problem again was just asking for x. From now, it's going to start to ask us to plug values in. So it's going to ask us for some other things. So in problem 3, we're going to use the same strategy that we used in the last problem, where if I see diameters, so BD is a diameter and AC is a diameter, that those create vertical angles. And so that means that the two angles that I'm given are actually equal. So I can take and say that 8x plus 12 is equal to 10x minus 22 because I have vertical central angles. So what I need to do then is move all the variables to one side and move all the constants to the other. So since I have 8 and 10, it's better to keep the 10 where it is. So I'm going to subtract 8x from both sides. And then at the same time, since I'm moving the x's to the right, I want to move the numbers to the left. So I'm going to add 22 to both sides. Okay, so that's going to give me 8 minus 8 is nothing. And then 12 plus 22 means we've got 34. And then 10x minus 8x gives us 2x, and negative 22 plus 22 is 0. So if I divide both sides by 2, that gives us that x is 17. So now what we're going to have to do is plug in x into different pieces to figure out what these arcs are. So arc AD is the 8x plus 12. So I have to do 8 times 17 plus 12 to figure out the length of arc AD. And so that's going to be 148 degrees. For CD, that's this arc here. So if I know that this is 148 and this is a diameter, I have to do 180 minus 148, and that will tell me the length of arc CD, which is 32 degrees. Okay, so then finally, they want us to find arc B to D to C. So if I think about that one, from B to D is 180. And then we just determined that this little piece from D to C is 32. So that means that if I do 180 plus 32, that's going to give us that whole measure, which gives us 212 degrees. Okay, so we're almost done. Let's look at the last two, which just have more things going on. And so if I am given a problem, I always want to find diameters. And so J to L is a diameter, so I know that's a straight line, and M to K is a diameter. So that's good because notice I know two things on one side of the diameter. So that means that I'm going to add these two pieces together and set it equal to 180 because I know that this whole arc is 180 degrees, and I know the two pieces of the arc are those expressions. So I'm going to take 5x plus 23 and add that to 17x minus 41. And then combine like terms and solve for x so that I can answer the rest of the questions. So if I have 5x and 17x, that means that we can combine that to make 22x. And then 23 minus 41 combines to be negative 18. And that must be equal to 180 because I have a diameter. So it forms a semicircle. So then what I want to do is isolate x. So I'm going to add 18. So that gives us 22x is equal to 198. And then dividing by 22. So I didn't change colors. Dividing by 22 gives us that x is 9. So if x is 9, we can now answer these problems. So arc JK is the arc here, the blue one. So I'm going to plug 9 into that. So 5 times 9 is 45 plus 23 gives us 68. The arc MJ, if I think about this, these are vertical angles. So arc MJ is the same as arc LK. And so I can plug into that one. So 17 times 9 minus 41 is going to be 112. I could also do this using 180, right? If I know that this piece is 68 now from J to K, I can do 180 minus 68. That would have also worked to get that 112. So then my last one is LMK. So L to M to K. So L to J is 180 plus I have that extra 68. So if I do 180 plus 68, that's going to be 248 degrees. Okay, so this last one is a little bit more complicated because we don't have any diameters. So notice that I don't have any straight line, right? So in order to connect from V to Z to X, I have to kind of curve. I can't do a straight line through there. So that means that I don't have a diameter. What I do have instead though, is a measure or an expression for each wedge of my circle. So notice that I know everything. So that means that in this case, I can use the idea that a whole circle is 360 degrees and then add each piece together, meaning I've got 8x plus 21x minus 12 plus 10x plus 9 plus what is 90 degrees. Okay, so what I want to do is I want to combine all of my like terms. So looking first at my variables. So I've got 8, 21, and 10 with x's. So 8x plus 21x plus 10x is going to give us 39x. And then we've got 99, if I think about this, minus 12, and so that's going to be 87. So 39x plus 87 is equal to 360 degrees. And so what we want to do to isolate then is subtract 87 from both sides. So that's going to give us 39x is equal to 273. And then dividing both sides by 39. Tells us that x is equal to 7. So if x is 7, we can use that to find each of these arcs. So the first one it's asking us for is from W to X. So remember, shortest distance from W to X means that it's asking for the blue one. So it wants us to do 21 times 7 minus 12. So 21 times 7 minus 12 is 135 degrees. I'll make a mess with highlighters on this one. So then YW, so from Y to W, shortest distance would be this way, right? This would be longer than 180. So from Y to W, I've got 90 degrees plus 8 times 7. What color is that one? Red. So if I do 90 plus that 56, that's going to be 146 degrees. Y to X is the green one. So from Y to X is that one. So I'm going to do 10 times 7 plus 9. So that's going to be 79 degrees. And our final one is from V to W through X. So I'm starting at V, going towards X, and stopping at W. So I think the best way to do this one is just to add up all the pieces that we found, because we already know that the 10x plus 9 is 79, and we know that this one is 135. So adding is always easier than subtracting. So if I do 90 plus 79 plus 135, that gives me 304 degrees. So that is arcs and central angles.